Let's start solving the first internal test, part A, that is statistical characterization of feedback data. Moving on to the first question. So, the first question is give three more commonly used statistical measures for characterizing dispersion in student feedback data. Example, variation in teaching quality scores, lab facilities ratings, or peer collaboration effectiveness. Discuss how these measures can be computed effectively in large student database. So the three key measures are first variance, standard deviation, and interquartile range, that is IQR. So the first is variance, that is denoted by sigma square. So it is the average of squared deviations from the mean. Its formula is sigma square is equals to summation of xi minus nu whole square divided by n, and it can be computed incrementally using the formula sigma square is equals to e of x square minus e x of whole square. You only need to maintain sum of values and sum of squared values. Second is standard deviation, that is denoted by sigma. It is the square root of variance. Its formula is sigma is equals to under root of variance, that is sigma square. Once variance is computed in one pass, standard deviation is just a square root operation. Same unit as original data. Is its an advantage, making it interpretable. Now the third is interquartile range, that is IQR. So it is the difference between 75th and 25th percentiles. It is denoted by or calculated by, that is Q3 minus Q1. So the IQR, that is interquartile range, is equals to Q3 minus Q1, and it uh, can be computed using approximate algorithms like t-digits or p square algorithm that works in streaming fashion for large data sets. Its advantages is robust to outliers, which is very important for feedback data with extreme ratings. Now, why these are efficient for large database? So they can be computed using streaming algorithms. They don't require storing entire dataset in memory. Third is variance or standard deviation need only running sums. Fourth is IQR, that is interquartile range, can use sampling methods for approximation. Now, moving on to the second question. So, the second question is suppose that the student feedback rating on a scale of 1 to 100 on faculty mentoring effectiveness is given in sorted order, that is 13, 15, 16, 16, 19, 20, 20, 21, 22, 22, 25, 25, 25, 25, 30, 33, 33, 35, 35, 35, 35, 36, 40, 45, 46, 52, and 70. So in this question, there are six to seven parts in which it is asked. First, in A option, it is asked what is the mean rating, what is its median. The second B is what is the mode of the data, comment on its modality, that is it is binomial or trinomial or unimodal. So okay, now the third is C. In C part, it is asked what is the mid range of the data. D is estimate the first quartile, that is Q1, and the third quartile, that is Q3. E is give the five number summary of the ratings. Fifth, F is draw a box plot of the data. E is how is a quartile plot different from a quartile plot in this content. So the data is given, and the number of observations are 27. So we need to calculate mean and median in the first part. So the mean is calculated by the sum upon the total number of observations. So we get here 814 divided by 27, that is 30.15. Now for the calculation of median, since n is equals to 27, odd number, the median is the middle value. So the position of median, that is n plus 1 by 2 is equals to 27 plus 1 by 2, that is 14th position. So on counting the 14th position, we get the median as 25. Now the B part is to calculate the mode and modality. So finding the mode by counting the frequencies. So in this table, you can see that we have 35 four times, 25 four times. So we have mode as 25 and 35. So the modality is binomial. So because we have two modes. This suggests two distinct groups of student perception. That is, first one group rating around 25 and the another group rating around 35. This could indicate different student expectation or teaching effectiveness varying across different sections or batches. Now, third is mid-range. So to calculate the mid-range, we need minimum and maximum, and the sum of these two will be divided by 2. So here we have minimum as 30, maximum as 70. So 83 divided by 2 will give us 41.5. So the mid-range of 41.5 is significantly higher than both the mean, that is 30.15, and median 25, indicating the presence of high value outliers pulling the mid-range upwards. Fifth, now we have D as first quartile and Q1 and the third quartile, that is Q3. So we need to calculate this. So in this, we have Q1 at 25th percentile. So the position is equals to n plus 1 divided by multiplied by 0.25. That will give us seventh position. So the seventh position value in the sorted list is 20. So our Q1 is equals to 20. Now Q3 is equals to 75th percentile. So it is calculated by n plus 1 into 0.75. So we get 28 into 0.75, which will give us 21st position. So in the 21st position, we have 35. So our Q3 becomes 35. Now, for the verification, we have 25% of data which is less than equal to Q1 is equals to 20, and 75% of data which is less than equal to Q3 that equals to 35. Okay, so now moving on to the fifth part, that is E part, 5 number summary. So in this, we need to give 5 number summary, that is minimum, Q1, median, Q3 and maximum. So minimum we have 13, Q1 first quartile we have 20, median we have 25, Q3 we have 35 and maximum is 70. So in this table you can see this minimum as 13 and all the values are given. Now in the F part, it is asked for to draw the box plot. So to calculate box plot, we need to calculate check for outliers fences. So lower fence is equals to Q1 minus 1.5 into IQR, that is 20 minus 1.5 into 15, which gives us minus 2.5. And for the upper fence, we have Q3 plus 1.5 into IQR, which gives us 35 plus 1.5 into 15, which results in 57.5. Now, the lower is 13 is greater than minus 2.5, and an upper we have 70 greater than 57.5. So this is an outlier because it is true. So uh, the second step is to draw the box plot. So here we will draw the box plot as minimum, Q1, median, Q3 and the non-outliers, that is 52. And now the G part is we need to compare between quartile plot versus quartile plot. So the expect we will take as comparison. So in quartile plot we have data versus its own quartiles, and QQ plot we have data versus theoretical distribution. In expect, if we take as x-axis, so it's percentile quartile plots, percentile is from 0 to 1, and QQ plot percentile is theoretical quartiles, example z score. What is the purpose of quartile plot? That is understand data distribution. And quartile plots purpose is test normality or compare distributions. The interpretation of quartile plot is that it shows data spread patterns, and in quartile plot it shows fit to reference distribution. The diagonal line. So the quartile plot has no reference line, and in quartile plot we have diagonal is equals to perfect fit theory. In quartile plot, we use as exploratory data analysis, and in quartile plot, we have distribution or testing validation. Now, we have completed our two questions of part A. Moving on to the third question, that is, suppose student lab infrastructure satisfaction scores are grouped into intervals with the following distribution. So in this table, it is given score ranges from 1 to 5, 6 to 15, 16 to 20, 21 to 50, 51 to 80, 81 to 110. And the frequency is given as 200, 5, 450, 300, 1500, 744. We need to compute an approximate median satisfaction score for the students. So to find the approximate median, the first step is to find the total frequency. So the total frequency is 3194 students. Now finding the median position. So median position is equals to n by 2. So we get 3194 by 2 is equals to 1597. Now find median class using cumulative frequency. So we have class, frequency and cumulative frequency. So the cumulative frequency is calculated by frequency. So the first is from class 1 to 5 we have 200, and from class 6 to 15 we have 450 plus last cumulative frequency, that is 200. So we get 650. Then 650 plus 300, we get 950 and so on. So the median class is 21 to 50. So the cumulative frequency uh, will be 2450, which is greater than 1597, which was our median position. So now the step 4 is apply median formula. So the median is L plus n by 2 minus cumulative frequency upon frequency, and whole will be multiplied by h. H here is class width. So the L is lower boundary of median class, that is 21. N by 2 is equals to 1597. Cumulative frequency before median class is equals to 950. Frequency of median class is equals to 1500. And H, that is class width, we have 50 minus 21 plus H is equals to 30. So here median we get as approximately equal to, if when we put the values in the median formula, we get median approximately is equals to 33.94. So the interpretation in this, that about 50% of students gave a satisfaction score below 34, indicating moderate satisfaction with lab infrastructure. Now moving on to the fourth question, that is the last question of part A. So in this question, the question is given as, in the Department of Lifelong Learning, a feedback survey collected both student age and their self-assessment of learning productivity percentage for 18 students. So in this, the age is given and its percentage, learning productivity percentage is given for 18 students. Now in the question, there are three parts. In the first part, it is given to calculate the mean, median, and standard deviation of age and percentage productivity. B is draw the box plots for both. And third part is given that draw a scatter plot and a quartile plot to study the relationship. So first we will solve the part A. So for age, the step 1 is to calculate the mean. So we will do the sum of all the ages divided by the total number of students, that is 18. So we get the mean age is equals to 46.44 years. Now the step 2 is to calculate median. Since n is equals to 18 students, so the median is the average of ninth and 10th values. So the sorted ages will be 50 and 52. So because the ninth value gives us 52, ninth value gives us 50 and the 10th value gives us 52. So the median age is equals to 50 plus 52 divided by 2 is equals to 51 years. Now the third step is calculate standard deviation. So the formula is sigma is equals to under root of summation xi minus me, that is denoted by nu, whole square divided by n minus 1 using sample standard deviation, that is n minus 1. So we get the sum of square deviation is equals to 2970.38 and variation is equals to standard deviation, sum of square deviation upon n minus 1, that is 18 minus 1 is 17. So we get as 174.73, and standard deviation age, if we calculate in the formula given above, so we get as 13.22 years. Now for productivity percentage, we need to calculate the mean first. So the mean is 518.1. Mean productivity is equals to 518.1 divided by 18. That gives us 28.78 percentage. The step 2 is to calculate median. So first sort the productivity values, that is 7.8 till we have 42.5. So the ninth value is equals to 30.2. The 10th value is equals to 31.2. So the median productivity is equals to 30.2 plus 31.2 divided by 2, which gives us 30.7 percentage. Now the third step is to calculate the standard deviation. So in the same way, we will calculate the standard deviation and put the values in the formula given before. So we get as a standard deviation productivity, we get as 9.25 percentage. Now the summary is given in this chart. You can see this. Mean age is 46.44 years and its productivity is 28.78 percentage. Median is given as 51 years, which is 30.7 percentage. Standard deviation is 13.22 years, which is 9.25 percentage. Now we will solve the B part, that is draw box plots for both. So box plot for age, we will be required 5 number summary calculation. So 5 number summary calculation, in this we have minimum as 23, Q1 as 36, because the fourth position is 27 and fifth is 39. And when we put these both in the formula, we get as 36, median 51 already calculated, and Q3 as 0.75 into 19, we get 14.25, that is between 14th and 15th values. So 14th value we have 57 and 15th value we have 58. So our Q3 becomes 57 plus 0.25 into 58 minus 57. So we get as 57.25 and maximum we have 61. So our IQR, that is Q3 minus Q1, becomes 21.25. So you can see in the diagram, we have age blockplot in which we have plotted the minimum, Q1, then medium, then Q3, then maximum. Now we need to check for outlier. So the lower fence is equals to 36 minus 1.5 into 21.25, which gives us 4.125. Low and upper fence, which is equals to 57.25 plus 1.5 into 21.25, which gives us 89.125. So we have no outlier here because all the values between 4.125 and 89.125. So now we will see the box plot for productivity. So now here also we need to calculate the 5 number summary. So the minimum we get as 7.8, the Q1 will be 26.35, median as 30.7, Q3 as 34.225, the maximum is 42.5, so the IQR will be 34.225 minus 26.35, which will be 7.875. So in this diagram, you can see this box plot productivity diagram in which we have mentioned the minimum, Q1, median, Q3, and maximum. Now, just a second. Now we will check for the outliers here also, the lower fence and upper fence. So we get the lower outliers are 7.8 and 9.5, and both are less than 14.5375. So these are the outliers, lower outliers, and here we have no upper outliers. Now the interpretation for this is two low outliers, that is 7.8 percentage and 9.57 percentage. There is some students with very low productivity, and second interpretation is median slightly left to center in box, slight right skew. Third is most students, that is 50%, have productivity between 26 to 34 percentage. Part C is, now we will solve the part C, that is scatter plot and QQ plot, that is quartile plot. So the scatter plot, that is between age versus productivity. So plotting age in x-axis and productivity percentage in y-axis. So this is the graph you can see here. So the key observations are positive correlations: as age increases, productivity tends to increase. Two outliers at bottom left. So the young students 23, 27 with very low productivity, that is 7.8 percentage and 9.5 percentage. Now the moderate spread is not a perfect linear relationship but clear upward trend. Estimated correlation, that is R, is approximated equals to plus 0.7, that is moderate, strong, positive. So this was all about scatter plot. Now we will see the quartile plot, that is age quartiles versus productivity quartiles. So in this we need to sort both variables and plot corresponding quartiles against each other. So paired quartiles, that is first will be 23, 7.8, second will be 23.9.5, ninth will be 50, 30.2, that is median, and the 18th will be 61.42.5. So the interpretations are low end. First is low end, that is points fall below diagonal, that is younger ages have disapproximately low productivity. The middle has points close to diagonal, that is similar distribution in middle range. Upper end, we have points near or slightly above diagonal, that is older ages have good productivity. So the overall interpretation is slight S curve indicates different distribution shapes, but generally positive relationship confirms. And this is our quartile plot you can see in the diagram. So this was all about part A. We have solved 4 questions in this. The next questions of part B, C and D we will be solving in the next other videos. Till then, thank you.